Yes, Norton theorem is related to constant current source and Thevenin theorem is related to, yes, anyone. Norton theorem is related to constant current source and Thevenin theorem is related to constant voltage source. See, I'll underline. This is the constant voltage. Therefore, I will write Thevenin theorem is related to constant voltage and Norton theorem is related to constant current, current source and parallel resistance. This is series. And series means what? Suppose there are two resistors are connected in series. Suppose R1 and R2 connected in series. Therefore, total resistance we can write, dear student, here I will write. Suppose there are two resistors are connected in series like R1 and R2. And for this it implies that RS equal to, can I write dear student R1 plus R2?
Yes, sir.
Very good, nice. Suppose there are two resistors, suppose R1 and R2 are connected in parallel. Therefore, for this we can write 1 upon Rp equivalent parallel resistance equal to 1 upon R1 plus 1 upon R2. Okay, or you can write, and from this we can write, this implies that 1 upon Rp, 1 upon Rp, dear student, is equal to R1 plus R2 upon R1
Upon
plus
R1 into
R2.
R2.
Or you can write Rp equal to R1 R2 upon R1 plus R2. Understood, dear student? And can you tell me any one application of series resistance in your daily life? Anyone? Yes. And okay. Now see, what is the statement? Now I will explain all a statement of this statement. Now see, dear student, see, I will shift this. In exam, I will ask only statement and then you can draw diagram. Now see, in Norton theorem, any two terminal active network, see dear student, see this is the important word I will underline. Any two terminal of active network, any two terminal active containing voltage sources and resistance. When viewed from output terminals means, dear student, these are the output terminals. Okay, when viewed from output terminals, okay, is equivalent to constant current source. Dear student, this is constant current source. See, see, this is your constant current source. And parallel resistance. And what? Parallel resistance. And dear student, this is your parallel resistance. Understood? And this is about, and this constant current is equal to the current which would flow in short circuit place terminal across the terminal. And this is your, see, means in Norton theorem you should draw diagram C, which is consists of constant current source and parallel resistance Ri. Okay, and now see, or in another words, you can write statement for Norton theorem like this. I will shift this again, or you can write, dear student, see, the voltage between any 2 points. Dear student, the voltage between any 2 points in a network is equal to IAC. And what is the IAC? S for, dear student, S for short circuit current. See, voltage. What is the formula for Ohm's law? Hello, dear student, V equal to IR.
IR.
Okay, and therefore we can write instead of this I, suppose I equal to ISC, S for short, and short circuit, and C for current. Therefore, IC for short circuit current. And suppose R equal to your internal resistance, which is parallel to the constant current source. Therefore, we can write, yes, dear student, I instead of I, can I write IC? Yes or no?
Yes.
And R, I can write. And this
RI.
is which theorem? This is Norton theorem. कौन सा theorem है? Norton theorem. Means in case
Northern.
of Norton theorem, voltage between any 2 point of network is equal to current into resistance. But current क्या है? What is your current? Current is your short circuit current, and Ri is your internal resistance. Okay, and therefore here therefore, in this case, in Norton theorem, replace your constant voltage source by constant current and connect parallel resistance. And this is about the constant. This is about the Norton theorem. And dear student, in case of Norton theorem, the circuit may see if your circuit is with constant voltage. Suppose your circuit is with constant voltage source and resistance network. Therefore, remove that voltage, constant voltage source with constant current source and resistance with parallel network. Very good. This is your network with constant voltage source as well as resistive network, and replace that constant voltage with constant current source and resistive network with parallel resistance. Okay, and this is about the Norton theorem. Understood, dear student? What is the difference between Thevenin and Norton theorem? Thevenin theorem is related to constant voltage source and series resistance.
Voltage.
But Norton, yes, a constant voltage source and series resistance, and Norton theorem is related to constant current source and parallel resistance. With Henry. Understood, dear student? And this is also referred to as a dual of Thevenin theorem. With Henry. Understood? Thevenin theorem is only reduces two-terminal active network of linear resistance and generates constant voltage source and series resistance, whereas Norton theorem replaces your network by equivalent constant source and parallel resistance. This is about the Norton theorem. Can you write about the Norton theorem? And this is a diagram. Okay, dear student?
Yes.
Yes. Now, I will power P equal to product of V and I. Is it correct? See, next point is maximum power transfer theorem. And dear student, power is the product of V and I. Is it correct? Hello student.
Yes.
I will write here. Yes. Now, maximum power transfer theorem is also known as okay. And we know that power is equal to V into okay. But what is the Ohm's law? We know that by Ohm's law, yes, student, can I write Ohm by Ohm's law? Can I write V equal to IR? Hello, student, yes or no? Hello, student, anyone? My audio is clear?
Yes, sir.
Okay. Dekho, see, power equal to V into I, is it correct? Anyone say can yes?
Yes,
Yes,
sir.
Okay. But by Ohm's law, V equal to IR. Therefore, suppose this is your P equal to, can I write P equal to, what is the V? V equal to IR. Therefore, IR into R. Therefore, it is the square of current flowing through the circuit. Can I write I square R? Therefore, if you want to find out power, if you want to find out power, you should know current as well as resistance to the circuit. Understood, dear student? Hello. Means
Yes, sir.
from the knowledge of current and resistance, you can find out the power. And dear student, we need maximum power, maximum efficiency. Understood? And for this case, then I will explain what is the criteria, what is the condition, what is the requirement for to uh, to get a maximum power from a particular circuit. Now see, and now dear student, uh, see statement. This theorem is applied to what? DC network. Which network? DC network. Now, I have already explained about the AC and DC. Yes or no? What is the difference between AC and DC? Hello, student.
Sir, AC में polarities keep changing.
Yes, yes. And DC may current will flow in only one direction, maybe positive or negative. Now, see, this theorem is applied to which type of network? DC network. Now, see, dear student, see the statement: a resistive load will extract maximum power from network when the load resistance important is load resistance, and here student load resistance is denoted by RL. L for load, R for resistance, and is equal to important what is equal to the resistance of the network. Resistance of the network, and all the energy sources removed, leaving behind their internal resistance. See, means RL is equal to internal resistance. This is the formula. Dear student, if RL equal to RI, if external resistance is equal to RL means external resistance. RL means, dear student, external resistance. And if external resistance, my audio is clear? Hello.
Yes, sir.
Yes, sir.
And maximum power, if you want maximum power to that a particular circuit, then condition is what? Condition is if internal resistance is equal to external resistance. Dear student, external resistance is also referred to as load resistance. A than metaphor. There are different ways to write a statement of maximum power transfer theorem, that is MPT. Okay, and simple statement is what? If external resistance or load resistance is equal to internal resistance, therefore you will get the maximum power, that is you will get the maximum P, that is I square into R. And from the knowledge of current through that circuit and resistance, which resistance? Load resistance, external resistance, we can find out the power. Now see circuit diagram for this here. I will now see circuit diagram. Laser pointer. Now see. Dear student, see, this is power source plus or electromotive force generator, GNE generator of your electronic force power, okay, or voltage source is connected to here resistance. RG is your resistance and R. Dear student, RG and G are two resistors are connected in series. Yes or no? Hello student.
Yes, sir.
RG is internal resistance of this instrument. ये जो इंस्ट्रूमेंट है ना पावर सप्लाई है ना उसका इंटरनल रेजिस्टेंस इज RG and R is, dear student, R is series resistance which is connected in series with RG. Therefore, what will be the total resistor? Total resistor we can write R plus
RI.
yes, R plus RG. Therefore, see here, dear student, see your right hand side. Ri is Rg plus R. That is the internal resistance of the network. See, dear student, this is network. See this dotted line. This is I will write. Best way is I will write here. This is your network. This is your network. And for that, for this network, resistance is equal to Ri is equal to Rg plus R. Why I am adding R? Because internal resistance is here equal to Rg is connected in series with R. Therefore, total resistance of that network जो मैंने circle किया है ना green color से, that is Rg plus R. Understood? Because capital R is connected in series. Understood, dear student? And dear student, A and B are output terminals. Now see, A and B are, hello, A and B are output terminals. Okay, and our aim is to find out the condition criteria for maximum power. Now RL is your RL is RL, L for load. RL is load resistance which is connected across which point? Anyone? Hello student. Which point? A and B, connected at point A and B. Now see the theoretical explanation. I will use see figure A. This is figure A. Dear student, if you have any doubt, you can ask during session. This is your figure A. Okay. Now in figure A, see the theoretical part. I will use laser pointer. Now dear student, see load resistance RL is connected across point A and B, which consists this network is consist of generator E, Rg and R, which Rg and R in series. Okay, and therefore we can write RL equal to Rg plus R, that is internal resistance of the network viewed from A and B, viewed from this side like this. When you are viewing from this side, from A to B, R and Rg are connected in series. Now see the next point. See, and according to student, yes. See, according to theorem, RL will extract. Will extract means will take, and maximum power from the network when RL equal to Ri. Understood, your student, up to this level? Hello, hello, student. Anyone say can yes? And therefore, dear student, therefore, current through current through the circuit, we can write what is the current? Current I will flow through this circuit, and this can be written as current I. What is the formula for dear student? Here I will write by Ohm's law. We know that V equal to IR. Which, if you want to find out current, therefore I equal to V by R.
V by R.
But in this case, V is equal to what? E. V is equal to what? E. And R is what? Total resistor. RL plus Ri. Is it correct, dear student? Hello. Therefore, we can write, dear student, equation number 1, that is E equal to, understood, dear student, equation 1. Anyone second? Yes. Hello.
Yes, sir.
Dekho. By Ohm's law, based on Ohm's law, we can find out equation 1, that is I equal to E upon RL plus RI. RL is your load resistance, Ri is your internal resistance. Now, our aim is to find out the power consumed by load resistance. And we know that, I will write here, see, we know that, P equal to, dear student, can I write I square R? Hello student, can I write P equal to I square R? Anyone? See, P equal to VI, but V equal to IR into I square. Right. But we need power through only load resistor. Therefore, we can write, instead of R, we can write RL. We can write RL. Therefore, PL is equal to I square RL. Understood, dear student? Therefore, this is the formula. And therefore, dear student, what is the I? What is the I? E upon RL plus RR. Is it correct? Square into RL. Equation number 6. Understood, dear student, up to equation number 2? Hello, student. Hello, student.
Yes,
Understood
sir.
equation 2? Don't by heart answer. Okay. Therefore, PL equal to PL is power consumed by load resistance. Power consumed by load resistance RL, and that is equal to I square into RL. Put the equation number 1 in this equation, and you will get equation number 2, which is E square upon RL plus RI bracket square into E by RL upon plus RI bracket square into RL. Okay. And now, dear student, using maxima and minima condition, in mathematics or in differential equation, if you want to find out the maxima, first take single derivative or first derivative, equate to 0 and find out the answer. Now see, these are the mathematical functions. And dear student, yes, any doubt up to this level? हेलो स्टूडेंट, लिख सकते हैं ये आप? देखो मैंने स्टेप बाय स्टेप पूरा दिखाया है आपको. आई विल शेयर ऑल दिस विथ यू, एंड नेक्स्ट लेक्चर I will take the numerical problems based on this. Okay. Yes. Any doubt? देखो, I will take summary of today's lecture. पहले हमने क्या देखा? हेलो स्टूडेंट, can you tell me
Norton theorem.
yes, can you tell me summary of today's lecture? Yes, Norton theorem. Norton theorem में क्या difference है? और yes, what is the difference between Thevenin and Norton theorem? Anyone?
सर थेवेनिन थ्योरम में वोल्टेज होता है और वो सीरीज में होता है.
Okay. और सीरीज में होता है, बराबर है. और क्या होता है? और नॉर्टन थ्योरम में
करंट एंड इन पैरेलल.
करंट इन
constant
ओके
constant
कांस्टेंट होता है. ओके. और yes, dear student, see, in case of Norton theorem, dear student, in case of Norton theorem, you will get constant current source. What is the difference? Constant, and this is about see, power increases at a maximum value, again decreases, and maximum power you will get at Ri equal to, dear student, maximum power you will get at uh, Ri equal to RL. And
RL.
this is the graphical behavior of power with respect to load resistance. Okay. In exam, dear student, in exam, first write all these first or circuit diagram, write statement, then write mathematical explanation, and then show that when Ri equal to RL, you will get the maximum power consumed by load resistance. Note down this expression and draw graphical behavior of power versus load. Thank you so much, dear student. Thank you all. If you have any question, you can ask. Okay. Thank you.